Hello, I'm Chandrasekhar Murapaka, faculty from Department of Material Science and Metallurgical Engineering at IIT Hyderabad. So in this semester, I'm floating a course on thin film technology on IIT platform, open to all. So I would like to give a brief introduction of what you are going to learn in this thin film technology. So basically, thin film technology is a backbone for the semiconductor industry. Right? We are going to learn starting from fundamentals of thin film growth up to the applications. In between, we will learn about what are the various techniques and what are the various instrumentations that we are going to use in thin film technology course. So the course starts with brief introduction of what are thin films and how thin films are grown, how atoms come together to form matter through nucleation and growth, and how to choose our substrates and thin films, and what is the role of vacuum technology in thin films we are going to discuss. So once this is over, we are going to go for physical vapor depositions. In physical vapor depositions, we are going to discuss about thermal evaporation, E-beam evaporation, and pulse laser ablation. Then we move on to a different technique and industry scale technique that is called sputtering, in which we will discuss about DC sputtering, RF sputtering, and magnetron sputtering. Right? And we will conclude our PVD with molecular beam epitaxy. Next, we will move on to chemical vapor deposition. The name itself says that it needs some chemistry to be there for formation of the thin films. So we need to create an ambience or an environment for the chemical reaction to happen. So we will discuss about various chemical vapor deposition techniques, types of CVD techniques such as atmospheric pressure CVD. Then we will discuss about low pressure CVD. Then we go to plasma enhanced CVD, and then we discuss that what are the advantages and disadvantages of each of these chemical vapor deposition methods and where they are going to be useful. For example, PECVD is mostly used in back-end of line where you need low temperature process. And we'll conclude our CVD by discussion of ALD, atomic layer deposition. Then we move on to a topic that is called epitaxy, that how to grow films with a particular orientation by giving a crystallographic relation between the substrate and thin films. We'll discuss about homoepitaxy, heteroepitaxy, and then effect of epitaxy on the properties of the thin films. Finally, we'll discuss about the characterization techniques that are specific to thin films. First, we will discuss about in situ and ex situ techniques to characterize the thin film thickness. What is the thickness of the film we are going to discuss. Then we move on to the structural characterization where we will discuss about GAXRD, grazing incident X-ray diffraction method. And finally, to know the chemical properties, right, we are going to discuss about XPS, X-ray photoelectron spectroscopy, and UPS, ultraviolet photoelectron spectroscopy. With this, we will conclude this course. So why you need to learn about this course? Because India is looking for Indian semiconductor mission, which is coming in a big way, where thin film technology is going to play a key role, right? So thin film technology, the learnings is going to be helpful to get you as a process engineer in this semiconductor industries. Besides theory, in this course, we are also going to show you the videos of practical hands-on experience of the students for all the techniques whichever I discussed just now, starting from thermal evaporation, E-beam evaporation, sputtering, PLD, APCVD, LPCVD. So you will get both theoretical knowledge and also get a feel of how these thin film depositions are going to happen. If you are interested, please enroll for this course. Thank you.